Hello everybody. In this video we are going to talk about abstract classes in Java. Now we have already discussed about inheritance, where we saw that a superclass is created and then from the superclass we create more specialized classes which are called subclasses. And this hierarchy can continue up to any depth. So as we move up the hierarchy, we find that the description becomes more and more generalized, and as we move from superclass to subclasses, the description becomes more and more specialized. So that's why this superclass subclass is also known as generalization specialization. So now, given this, we can think of a superclass to be so general in description that it may not exist in the real world. Let me explain this with an example. So here you can see we have a hierarchy where we have a class called shape and three subclasses: triangle, square and circle. So if you think, is there any way that you can create a shape which is not say neither a triangle or a square or a circle or any other shape which is defined? So here when we say shape, this is undefined. This is not defined in any way. So we can say that this is very general and it encompasses all types of shapes. So it may not have an existence in the real world. However, a triangle, a square or a circle very much exist in the real world. So this is one example. We can have this hierarchy one level further, where I may have a shape which can be either a two-dimensional shape or a three-dimensional shape. Again, a two-dimensional shape may be say a square or a circle, whereas a three-dimensional shape may be a sphere or a cube. So again, as we move down the hierarchy from shape to square, we become more and more specific. And in the same way, as we move up the hierarchy, we become more and more general. So we can safely say that a sphere or a 2D or a 3D, these will not exist in the real world, but a square, circle, sphere or cube will exist. So in such a situation, what we can do is we can derive these classes or we can make these classes, that is shape or 2D or 3D, which will not actually exist in the real world. We can mold them into a type of class known as your abstract class. An abstract class. So a shape or an abstract class will exist only for the purpose of helping out in creating subclasses. So they will only be super classes. They will only act as superclass. Okay, so I can make shape as a superclass, as an abstract class. I can make 2D as an abstract class. I can make 3D as an abstract class, because none of them will exist in the real world. However, square, circle, sphere and cube, I can make these as concrete classes. So the term is concrete class. Let me just write it here. Instead of abstract, this is going to be concrete class. So square, circle, sphere, cube, these are all concrete classes. So you have abstract classes which does not exist in real world and concrete classes which actually exist in real world. So why do we need these abstract classes? So as I have mentioned, they help in creating a hierarchy and reuse. So some features which are common to circle, square, sphere and cube can be put in the two-dimensional or three-dimensional classes or in the shape class. Okay, so these abstract classes will exist only for the sake of the hierarchy. What are the features of these abstract classes? First of all, an abstract class will provide a general structure, but it will not have any complete implementation. So, on the shape, I may have a class or I may have a method, let's say called area. I may have a method called area which returns an integer. Now, how do I compute the area of a shape? I have no way, there is no way I can compute it because there is no formula for it. Similarly, for 2D object, because 2D will inherit area from shape, so 2D also I cannot compute. But I can compute the area for square. Same way I can compute the area for a circle because I know how it can be computed. So these methods that we give inside our abstract classes, these are known as your abstract methods. These are your abstract methods. So in this abstract class, these methods will have no implementation. So it is just telling the hierarchy that the subclasses must have a method called area. That's it. So shape will not give any implementation for area, but this area method has to be overridden in the subclass. So this area method has to be overridden in the subclass. So now if you see here shape, for shape you have two subclasses here if you follow this line. So shape has one subclass 2D and one subclass square. So the area method has to be overridden either in 2D or in square. We can have the same along other parts also. So it becomes compulsory for either shape, for either 2D or for square to override the area method. If say 2D now cannot give an implementation for or cannot override the method area, in that case 2D also becomes an abstract class. 2D also becomes an abstract class. Okay. Now it is up to the class square to give a implementation for area. So when area method is overridden in the square class, then square no longer will not be an abstract class. Instead it will become a concrete class. So the methods that are defined inside the abstract classes, remember abstract classes may have concrete methods, that is regular methods, or it may have abstract methods. Concrete methods, it will give an implementation. Abstract methods, it will not give an implementation. So when I say it will not give an implementation, it means I'll write something like this. So I use the keyword, sorry, the spelling is wrong. Let me write it again. Abstract class shape. So I can create the class like this by adding the keyword abstract here. So abstract here is a keyword which I will use to create an abstract class. Now inside the shape, it can have data members. It can have its regular data members. It can have its regular methods. Okay, and it can have abstract methods. So how do we know again if method is abstract or not? Again by addition of the keyword abstract to it. So suppose I want area to be an abstract method. So I'll write it like this. Abstract. Return type is int. Name is area. Okay. And then here, instead of the body, I'm going to give a semicolon. So that's it. So now shape is a class, abstract class, which has its own data members, its regular methods, and an abstract method called area. So it becomes compulsory for the subclasses of shape to give an implementation or to override. So subclass must override area. Override the class, the method area. So if I have a class called square which extends from shape, okay, it may have its own data members, it may have its own regular methods, but it becomes compulsory for square to override the method. So int area, it must give a body to this method. So return, say, let's say L into B, length into breadth. So this is the area of the square. So here you can see that the method, the class shape was an abstract class. It defined a method called, an abstract method called area, which was overridden by the shape, by the square class. So the implementation is given by square, whereas definition is given by shape. Now, what is the advantage of this? Advantage is that it provides a general structure but no complete implementation, and implementation details to be filled in by the subclasses. So it becomes, if say area was not defined as an abstract method in shape, then there is no compulsion on the part of circle or square to define an area method. Okay, so it becomes compulsory for your subclass to give a body or to give an implementation to this abstract method. So it's like binding, saying that you have to give an implementation to area. So the abstract class is always meant to act as a superclass. So it is never a concrete class. So it's always a superclass in some hierarchy. Like say for example, again in this particular hierarchy, shape 2D square. So shape is an abstract class, 2D is also an abstract class, okay, but then both of them are acting as superclasses. So they have to act as a superclass. And another important point is that you cannot create an object of an abstract class. So if you try to create an object like this, shape S is new shape. Okay, if you try to give this, you will get an error. This will give you an error because you cannot create an object of the of an abstract class. Then it simply provides a structure to the methods that a subclass must implement. So this is again what I have mentioned, that it provides a guideline as to which methods must be implemented by the subclass. So this is your abstract classes. So we'll see one example of this in a next video.